I can give a little intro as you make your way up here, but we got another debate. This one is titled, Can Everything Fit on One Computer? I think this has been a tale as old as crypto. This sort of question, it's definitely influenced a lot of the scaling roadmaps of different ecosystems, and we only have 30 minutes today, so I want to get into the conversation. We can make our way down the panel this way. If everyone could just give like an introduction of who they are and like opening statement, if you will, about the debate. Like, where do you come up on the question, can everything fit on one computer? We'll start with Max.
Hi, everyone. I've been up here twice already in the last 2 hours, so you probably know me at this point. I work at Anza. We developed the Agave client, which is the primary client that runs Solana today. I believe that a single blockchain is certainly enough to run all of the blockchain applications. And the reason I believe that is because the way that computers work supports that argument. There's only one thing that could stop us from executing as many transactions as we want in the limit as we scale these things, and that is serial execution on a single thread. The slowest thing in computing is executing everything on one thread, and there is no solution from modularity that will help you execute consecutive writes or reads on the same state. So the only way we can deal with it is to try and silo state and deal with things concurrently. I would just say none of these like modular systems make any sense to address that hot state problem. And so they're all addressing a problem that doesn't exist, which we've already solved on Solana with parallel execution. And that's kind of my core thesis is computers have a lot of cores. We can run a lot of operations in parallel. You can either do that by making a new L2, or you can just run it all on one blockchain and have each of the nodes running these threads in parallel on their own box.
Hi, I'm Jill. I run a company called Espresso Systems. We are one of these modular blockchains, specifically focused on fast confirmations or fast finality for cross rollup state transitions and transactions. And as you can probably guess, I very much fall on the side that the future is rollup centric, that we will not have every application running on one chain. I think that it's fairly obvious if you look at considerations around not just scaling the technology, but also around go-to-market, brand considerations, distribution, that this is the way that things are going and will continue to go. And I'm excited to get into that conversation.
Hi, I'm Rob. I'm a founding engineer at Polkadot. I've been in this space for a long time. I don't think that we have very strong definitions in this conversation, but it seems pretty obvious that we are not going to be able to run everything on one thread or perhaps even on one chain. Depends what kinds of relative guarantees you want to have between transactions. So whether that's going to be ordering, whether that's going to be dependencies and state updates, things like that. We're obviously going to run into overheads with respect to state replication, especially with decentralization. I mean, it depends how tight you want to bring the system together. Like if you want to have something that's very close to centralized, obviously you can do more with that. But even so, there are still going to be overheads. And you can even see like how this is playing out at the very, very cutting edge of compute, right? Like what is NVIDIA's bottleneck for AI? NVIDIA's bottleneck is it's transmitting data, right, between chips. It's transmitting data across a bus. Even when you can parallelize, you're going to run into these overheads with communication and replication that are going to be significant. However, I do think we're going to be able to scale these things really far, like hundreds of thousands of transactions probably on relatively modest hardware. And I'll talk later about some of the work I'm doing with respect to that. So we might not need to run everything on a single system, but if you look at it in the end run, it's not going to be that way.
Hi, my name is Uma. I'm the co-founder and CEO of Succinct, a company building a ZKVM and decentralized prover network. My opinion is that we're obviously not going to be able to fit everything on one computer or one blockchain. And I think a lot of the proof is to look at something like Hyperliquid today, which is one of the most popular applications in crypto. And I would argue that that's something that you cannot build on something like Solana, a very performant blockchain today. And they had to go build their own system and own chain. So kind of the proof is in the pudding, even right now. And yeah, looking forward to the debate.
Amazing. It sounds like we might have a 3-on-1 battle here in terms of perspectives, but I think.
Well, we had to make it fair, right?
Yeah, exactly. We had to make it a little fair. There's definitely a lot of points you guys mentioned that I want to talk further on. The first, a lot of the answers came from sort of the technical side of things, answering the question from like a very specific, can we fit everything on one machine? So I want to explore that a little first. The first thing that comes to my mind when I answer this question goes back to when I first entered crypto, which is Vitalik's blog post and the trilemma. You had to basically choose between two of security, decentralization, and scalability. So I want to pose this question to the panel. I do want to ask Max first his opinion. Is the trilemma real, or is that just a psyop? And have you figured out ways to solve the trilemma?
Yeah, I think it's just completely fake. And I think like if Vitalik just stopped posting blog posts like right before that one, the world would be, we would be like 4 years ahead in terms of blockchain technology. That post, I think, is single-handedly responsible for setting the space back multiple years. And it's unfortunate when you're like that level of influence like Vitalik is, which he earned it. But when you're at that level of influence, like you shouldn't just like come up with something that isn't supported by any data whatsoever and just like what you think, and it's like just your opinion, man. But then because you're Vitalik, everybody thinks that's true. There's no data to support it. There's no proof. You can't make a proof because it's false. And you can do all three of those things pretty easily. We're doing it on Solana.
Can you give an example of a time when Solana has made a breakthrough in performance that has not traded off on decentralization?
Yeah, we make one every single feature flag we flip in the last. I mean, we have basically not changed the node requirements in the last 2 years, and we have way, way, way better performance today than we did then. In Agave 2.3, which is releasing, it's on testnet right now. It will be on mainnet in around 6 weeks. We have what is effectively only code level performance changes, just in the way that we execute the code, and it will allow us to replay 100 mil CU, which is double what we have today, on a single thread. And that's double what we have today, which is already 1400 TPS, which is already more than 100 times what Ethereum mainnet L1 processes. So almost every change we make is a change that doesn't sacrifice decentralization for performance. It's just pure performance because we're not even anywhere close to the Pareto frontier, even on Solana, which has a lot of performance engineering hours in it already.
So I would agree that we can continue to make incremental changes and incremental steps, but I think that every step function, at least that I've seen in my time in the industry, every step function change in terms of performance has involved some trade-offs on that trilemma. So I don't doubt that. I mean, even Ethereum itself, even at a slower rate of change, has continued to push the frontier incrementally. But I think that most step changes have involved a trade-off on that trilemma.
But define how big a step change is. Like, I mean, I'm just saying we've did performance improvements that made us basically. We are able to execute double the current number of transactions that we are now executing on a single thread. And you can then parallelize that. So that change alone is an 8x in the capacity of the blockchain. And it's all software, and it's not a trade-off. It's just using the resource that we have better. Like, that seems to me like a step function. So it like seems directly to counteract this point that no step function can happen without a decentralization trade-off, right?
Yeah, I mean, if I had to pick it out of thin air, I would say orders of magnitude. So 8x, sure, it's impressive, but Solana made a fundamentally different set of trade-offs in terms of node requirements than Ethereum, and that's how it initially, at least, achieved better performance. I won't lie. I mean, rollups make a different set of trade-offs as well from base layer Ethereum, and I think that Ethereum owns that. But I think that it's a hard thing to say that we are making huge rates of progress without acknowledging the reality of the trilemma. But I'm curious what the others have to say.
Yeah, I mean, I think something like it might be true, but I think we are pretty far from the efficient frontier. And I say this as an engineer. Like, I've been writing code on blockchain nodes for the last 10 years, like through Ethereum, through Polkadot, through neutral stuff. I think one of the lowest hanging fruits, or this is most obvious, is at the database level, where I've been working for the last year. So we've created a open source database called NOMT that's nearly optimal Merkle tree. And essentially, like, a lot of blockchain nodes are just bound by how fast they can fetch and write data to the disk, right? Like, it's an enormous bottleneck. Like, you would not believe how poorly the hardware is being utilized. And this is just a trade-off of, like, the designs are bad and the code is bad. And just fixing that, like, you can immediately get like an order of magnitude boost of performance. So I think, like, maybe in abstract, something like the blockchain trilemma is true. To be honest, I don't think we're at the stage where we necessarily need to worry about it. Like, we're not at the efficient frontier.
If you move the goalposts enough so that, like, you say in a hypothetical world that it doesn't actually exist today, you wouldn't be able to achieve 1000x performance without compromising, because of course there exists some Pareto frontier eventually. It's just like, does that mean anything practically for actual blockchain developers today? No, it should not inform any decision making in the process of actually building a blockchain today.
But even deploying a new DB like NOMT to something like Solana today would be very, very difficult, right? Because it's a live system. It has a ton of TVL. You're not just going to yeet a whole DB upgrade on mainnet like anytime soon. So I would kind of argue that the best way to test your new optimal performant data structure is actually on a new chain that's built from scratch. So I think other than performance, there's also a lot of other benefits of having multiple different environments. You can experiment a lot more freely. You can make very, very different trade-offs, which, for example, the L2s do. A lot of them have centralized sequencing, which leads to much better results. So even beyond performance, I think there's other characteristics of like the trilemma that maybe are important to kind of touch on, or reasons why you might want multiple chains.
I mean, it's funny that you mentioned that, because we're experimenting right now with changing our disk writes and reads to asynchronous with like standard stuff in the Linux kernel. And, we are able to do that because our system is set up so that we can actually iterate and develop. Of course, we still go through a ton of testing, but we do things like direct mapping, which says, instead of copying the data over and over and over again, we keep it in the same spot and just read from it. And we pass pointers instead of passing the data. Like, these kinds of things are possible on Solana if you have a functioning core dev process. It's impossible if the way that you make decisions is like who shouts the loudest on Twitter. And it is possible if the way you make decisions is like, what does the bench actually say? And let's do that thing that makes it the fastest.
One thing that Uma mentioned is the question is not only answered by performance itself. There are like other things you need to consider. I do want to touch on that in a moment, but I want to dive down this performance route with one more question, which is, do we think we've hit a limit with what we can do on one machine? If not, like, where do we think that maxes out? And I want to pose this to Max as well. Like, you probably would disagree that we've hit a limit. If so, like, what is that limit, if there is any?
I mean, we know we have internal benches where, especially if the transactions are parallelizable, we can hit 1 million TPS. We have internal benches that are showing that. Obviously, those are simple transactions, they're transfers, and they're parallelizable. But my guess would be, for the type of mainnet traffic that we have right now, I know concretely what the next 8x is. And then I think there are kind of unknowns that are going to be revealed to us as we get to that scale, that are going to be at least 100x in mainnet load for Solana in the next, I would say 3 or 4 years. And that will not be compromising decentralization, just pure, not having bugs in the implementation.
I'm curious.
How many SSDs do you do that with? Like 1 million TPS? Like, how many SSDs are on each machine?
I mean, TPS is pretty orthogonal to state growth if you price it the right way. So We don't have 1 million TPS today, but you can change the cost of state if you want to limit state growth. It is actually
like how many IOPS are you doing like to do that 1 million TPS? Like how many read and write IOPS?
Yeah, I mean, you're going to need to do it, but that's a pipe. It's a pipe. You can lay more pipes next to other pipes. The only thing that is like fundamentally wrong is if you have to do operations one after the other. If you have to do 1 million operations one after the other, that's a problem. If it's a pipe, we can lay more pipe next to
like,
the
I mean,
pipe.
yeah, like you can always add more SSDs, like, and then there are going to be some limitations on like literally how much data you can move through the motherboard of each node, right? I'm just sort of like pointing at the fact, like to answer your question, it's highly predicated on like how big your nodes are, right? Like if you can stack like, you know, a RAID array of like 16 or 32 SSDs on every single node, then yes, you're going to be able to get really extremely fast scaling on a single node because you have to read and write to disk. Or maybe you'll do it all in RAM and you'll just write it all, you know, later on, but you're still going to be bounded on some level by like the amount of writes that you have. So I think like, you know, yes, you are going to at some level going to have to trade off like, that's not necessarily decentralization, but it's trading off on node specs, right? Like what is the hardware requirement?
I mean, I guess I 100% agree that bandwidth is oftentimes the bottleneck in these situations. And it could be not just bandwidth between nodes, but within the node as well. That's kind of the Kevin Bowers view of the world. And we've, because FireDancer has come in and built, I think, across the Solana core dev ecosystem, we've embraced that view. At the same time, it's like, I don't think we are constrained by which chips exist today when we're talking about, you know, we could use the hardware better and get 10 to 100x performance. And then by the time we're finished doing that work, which is really hard, then we will have better chips and we'll be working on using those chips. And so I think I would agree that it's bandwidth. I guess I would say there's no fun when it's bandwidth constrained, you can lay more pipes. So that's what we're doing with 00, right? We're just going to like do it on private fiber instead of public internet, and we're gonna have more bandwidth because we foresee that being a bottleneck.
Sweet. We could definitely go on this forever, but I do want to pivot the conversation to these other things that we need to consider beyond performance. The first that comes to my mind is sort of the incentive structure, the economics of the teams building on these chains, whether to choose to build an application on, you know, an L1 or to build a rollup or something. A Polkadot parachain or pessimistic rollup, etc. So I'm curious, I'm going to extend this to the panel, whoever wants to answer it. Do you think, like, in my view, apps have the natural incentive to want to vertically integrate at some point? I guess I'll ask it to Max. Like, would you agree with that standpoint? And like from the Solana point of view or like the IBRL point of view, like what do you think is the incentive for apps to stay on one chain as opposed to vertically integrate?
I mean, we have all the users. So if you want users, you should stay on Solana. That's where they are. If you want to bring your own users and have them use a product, like, frankly, I don't really know why you're building on the blockchain. Like, it seems pretty marginal for your users. If you want to build a new app, like the next Pump.fun, you're much better off building it on Solana than on a completely new rollup with 0 users and 0 integrations and 0 onboarding. So I would say it's network effects. And when you have almost all the activity going on one chain, then the decision is obvious to build on that chain because you don't have to have anybody build new pipes.
Why didn't Hyperliquid build on Solana?
I don't know. They probably would have been doing even better than they are now if they had.
Wait, who did you say?
Hyperliquid.
Why didn't Binance build on Solana? I don't know.
Well, I think Hyperliquid is a really good example where they bootstrapped something from literally 0. They started with a chain with no users, no TVL, and they fully built it up because their app and product was a lot better. I also think Pump.fun is actually kind of a counterexample to your point because they don't really use that much composability of the chain. Like it goes from their Launchpad to then their own pump swap decks, which they could have deployed on their own rollup. And if we're in a world where people are using something like Privy, where you're taking your assets in your Phantom and then moving it into an application-specific wallet, which is a very common design pattern, who knows where that Privy wallet lives? It could be on your own rollup, it could be on Solana, it could be on Base. With good enough bridging and interop, no one really cares. So I actually think Pump could be totally, or an application like that doesn't use that much composability actually could be totally fine on its own island.
I don't know if I agree with that. I think the the end game for pump tokens is to be new tokens on Solana that are traded all across the ecosystem. So like you look at something like a Trump, which wasn't technically launched on Pump, but like it was launched on Meteora. Like you look at that end game and it's like this thing is all throughout the ecosystem. It's on all kinds of pools. And if that doesn't exist, if that end game doesn't exist, then the whole set of dominoes falls down. So you need to backwards induct from what does a really successful meme coin look like to have a meme coin gambling. It's like if you were playing slots and you never win the jackpot, of course that doesn't work. Nobody's going to keep playing if there's no jackpot at the end of the rainbow.
I think that one way to look at this is from the perspective of net new apps. So whether it's Hyperliquid or Pump or whatever, but I think another way to look at this is from the perspective of apps that already exist in Web 2 and are looking to come on chain. And so again, maybe, you know, distribution is less of a concern there, but there's a reason why Coinbase didn't like build an app or like build a domain on Solana. They launched Base. There's a reason why Sony didn't build an app on Solana. They're launching Sonium, right? Like there's a lot of these examples where just from a brand perspective, you know, you don't want to be viewed as subordinate to some other brand like the main chain, the L1, which would be the case today. And you also don't want to be dependent on the choices that that the L1 is making as the underlying infrastructure. You want to have customizability over what your stack looks like. And I think that even more so than performance, I would probably say, is what I think is going to be the driving factor to drive folks to launch their own chains and why we won't see things end up just on one computer or one chain.
So like your thesis is that the problem with running everything on a single computer is that big tech execs have too big an ego to be subordinate to like low level infrastructure. I don't know. One thing I would say about the Hyperliquid point is this is not anything against the point that we're making. It may be that this is an indictment of Solana in some way. It's like, hey, Hyperliquid is doing some things better than Solana today, but they're actively trying to run a similar playbook to Solana. They're not trying to like create a launch pad for other chains to launch on top of them. They're like trying to build a high throughput L1. That is also what we are trying to do, and we are competitors with them, and they're doing some things well that we're learning from. So I would say it's more in support of my argument than yours, Uma.
I'm curious on sort of when I think of potential benefits from launching on one chain, there's basically two. It's like shared state and distribution. Do you think that my characterization is correct, that like those are the values that you would get on a shared state? And do you guys think that like those things are valuable? So I guess both of those questions to the panel.
Yeah, I mean, definitely. Like if you go back all the way to the roots of where this space started, it was in, Bitcoin, proof of work, double spend problem, etc. Like these things are about preventing double spends. They're about providing ordering. Most of it is about economic activity that needs some level of ordering on it. I think that like if you look at it like, oh, you just need verifiable compute, then you just say, well, just use SPM1 for everything or something like that, some ZK solution. But ordering is so critical. But I don't think that everything needs ordering all the time. Like, and I think that this is a very short-sighted mistake that we tend to make in the crypto world. Is like, oh, you assume everything's going to be like pump.fun, and like most of the value is in being traded 24/7 constantly. Whereas a lot of the economic value, like represented in assets, is stuff that moves much more slowly, right? Like it changes hands slowly. These are things like retirement funds or sovereign wealth funds or things, and they need ordering every now and then, but they might not need ordering all the time. But they might need other things that are on chain. Or they might need relative order with other certain activities, but they don't need a total order with every other transaction that's happening in the world.
Interesting. So you would say like the key piece in the argument is like shared state is not that important. What about like distribution or maybe these other
I think like
things?
locally shared state is important. I think that the ability to dynamically form and reform those local bubbles of state is particularly important. I don't think that saying, hey, here is all the economic activity of humanity and putting that into one giant shared state bubble is going to be especially fruitful.
even if we just take TradFi as the benchmark, it's not how TradFi works. And you can just look at the different bubbles and silos that exist within TradFi, and it's a very well functioning system. I don't think any of us are sitting up here complaining about inefficiencies in that system, but exactly, you can have the beauty of a modular stack is that you can have an underlying shared state that everyone is posting to, whether it's on the order of seconds or minutes, but you can still have horizontal scaling coexist with that.
I guess I've been doing a lot of experiments recently, and one way to look at this is if you look at sort of in a block, how much does the shared state matter? How dependent are these things on each other? And in some cases, it's about like half of the block is things that are dependent on each other. And you can sort of construct that graph, and maybe you take the min cut and you let some things fall off. And those things that fall off when you do that, the cutting process, are the things that you're losing when you don't have shared state. And so in some ways, it's like a mathematical question is like, are those transactions, you can go look at which ones fall off, extremely valuable or not? And I think they are, based on looking at a few of them, but it is a empirical question that somebody could go do and just look at the transactions that people actually land, and do they touch the same state, and is that valuable?
Yeah, if you want to rebuttal that.
Just to clarify, you're saying that like half of the transactions don't depend on other transactions, and when you don't have shared state, you're losing those transactions?
No, the longest thread in the average Solana block is about half of the CU. So there are other dependencies in other parts of the graph. That's the longest path in the block of dependencies.
Well, I wish we had way more time to talk about this, but unfortunately our time is up. Appreciate everyone on the panel for all their answers. I think it was a great conversation, and yeah, appreciate you guys for coming out. Thanks, everyone.